Okay, so this goes on page 113 of your composition book. If you have it already, you can turn there right now and go through the notes with me. If you don't have it already, you're welcome. Just go to creatormath.com and go to page 113, right? So you can review it on your screen as we go through it. This is rigid motions number 4. It's rotations. Okay, use your hand or arm or some way gesture to me. What's a rotation? What is a rotation to you? Yeah, that is. Who else? Give me another one. What's a rotation to you? Give me some gesture. One, what's a rotation? Yeah? Yeah. Okay, good. Piece of cake, like you're like, I know what a rotation is, right? You okay with this? Okay, good. So it's this applied to a geometric shape, right? And kind of that's the basis of this one. And if you're going, wow, this sounds really easy, maybe it is, but it can get a little bit complicated in the details. So here's what we're talking about. Take a shape and rotate it. There's going to be instructions on the rotation. If you're going to rotate this shape, what do you need to know before you can rotate it? What do you need to know? What would you like to know, I guess?
Where the shape starts?
Where the shape starts. Very good. That's called the pre-image. That's where the shape starts. Good. Keep going on what he said and or keep going. What would you like to know next about, if I got to rotate this, what else do I need to know?
The way in which you, like direction?
Good. The way in which you rotate it or the direction, right? And how do we describe direction in rotations? We use the word clockwise and counterclockwise. Okay, in your mind, can you see which direction clockwise is? Use your hand or arm or something to tell me which way is clockwise. That's true. Who else? Which way is clockwise? That's true. That's true. How do you figure that out?
Clock normally turns from right to left.
Just look at our old school clock and see which way it turns, right? It turns that way. That's clockwise. You okay with this? And then what's the word counter mean to you?
Opposite.
Opposite. So if it's counterclockwise, it's opposite that direction of the clock. You okay with this? Okay, so 1, where does it start? 2, which direction are you rotating in? What else do you need to know about rotation? If somebody's telling you to rotate this, what else they got to tell you before you can know where it ends up? What else would you need to know?
On what axis?
On what axis, and we call that about what point, which is a little bit strange language. Okay, so you got to know, yeah, thank you. You got to know about what point it's being rotated. And maybe the easiest way is to take, if this is the pre-image, and I drew it kind of big on the board, I'm sorry about that, it doesn't fit on a piece of paper, but if this is rotating, triangle ABC, so here's ABC, that's the pre-image, that's the one we're rotating. It's counterclockwise, so it's going this way, the opposite of a clock rotation. And then it says about the origin. Where's the origin? The origin is at 0, 0, right? Go back to your old days of graphing and plotting points. The origin is the 0. What does the word origin mean to you? What's origin mean?
Starting point.
Starting point? Or beginning? Or, like creation. In the beginning, there was nothing, and then there was an origin, right? And that's where everything started from, right? Does this make sense? So in this case, it's rotating about the origin. If I draw the shape through the paper, and I drew it smaller because it doesn't fit on my paper, and then I pinpoint the origin, now I can see how this rotates. And I can see where it ends up. What's the last item you haven't mentioned yet that I need to know when rotating a shape? What's the last item? You mentioned, where's it start at? You mentioned about what point is it rotating? You mentioned which direction is it rotating? What's that last item? What's the one thing we haven't said yet? So here's a measurement of 90 degrees, and that tells us how far. Does this make sense? I need to know how far to rotate it. So in this case, I'm starting here, I'm at the origin, I'm rotating 90 degrees counterclockwise. That's it. They could have told me 180, I would have then ended up over here. They could have said 270, I would have ended up here. Does that make sense? So, 3 aspects of rotations. 1, about what point is it being rotated? X comma Y is the most common way to see that, although it doesn't have to be. Which direction, clockwise or counterclockwise, right? And how many degrees? How far do you want us to rotate it? Now the details get a little bit dicier at this point. If C starts at negative 2, 7, so here's the point plotted, negative 2, up 7 right here, so negative 2, 7. If it now rotates down to here, so you saw C come over to here, it gets a tick mark. What's the tick mark called? You remember?
Signifies congruency.
It signifies that it's the same point now in a new location. Okay, that tick mark in this case we call prime. Everybody say prime. Everybody try it. Everybody say prime. Try it again. Everybody say prime. Okay, good. Thank you guys. Thank you. It feels so hard to do it in the morning. Okay, so you've got C and C prime. Does this make sense? It was C. Now it's a new one. C tick mark, which is said C prime. You could have C double prime, which would be another place. Who knows where it could be, right? So you can keep saying that the point C is now moving to new locations, and the C prime tells you that. Likewise, A moves to A prime. B moves to B prime. The hardest part probably becomes, how do I know this coordinate location? Well, if I'm at negative 2, 7 up here, and now I rotate down here, it makes sense that now I'm at negative 7, negative 2, right? Which, if I'm writing this, I would love to see a negative on here. And, did I write that on? It is, it's on the notes. I just didn't put it up on the board when I did it. Which, by the way, there's an error on the notes that you're putting into your comp book. And I'm not going to tell you where it is at first. I'll tell you where it is eventually. But if you can find the error in the notes that you wrote on page 113 for this, I'll give you bonus points. What happened was when I wrote the original and then took a picture of it to put on the website for you to use as notes, I made a mistake. You okay with this? If you find it, I'll give you bonus points, which is a lot of fun sometimes if you can find the error. All right? And I'll tell you what it is eventually. I'll put it in a message and tell you what it is. Okay, so these coordinate points become the most difficult, probably complicated part of the rotation, right? You've got, okay, I understand rotation. You tell me which way. You tell me about which point. I rotate it so far. Now I got to come up with where these coordinate locations are. So a lot of it is kind of looking at it first and figuring it out, and then going to a mathematical formula of how to figure it. Just look at the idea that if this is negative 2, 2, and it goes down here in this coordinate, it's got to be negative 2, negative 2, which I hope I've written right. I've just been touching it a lot, so this is still a negative here, right? So B prime becomes negative 2, comma negative 2. A prime moves all the way down here. It's got to be 2 away from the y-axis now, so we have a negative 2 in the x direction to come over here, and it's got to be all the way down at negative 2 here to be part of that rotation. And the fact that we rotated around the origin is what makes it so logical for us to move this. If the rotation is out around some other point, this can get a lot more complicated, right? And we'll do some of those, but those will be additional to, like if you do the IXL bonus, then you'll start to get into some of those. Okay, what else is on the notes for rotation? Remember that math does not always go in order of difficulty, right? You may come into a math class and the first topic may be really difficult, and then the second or third topic may not be so difficult. I think this topic is kind of fun, you guys understand what rotation is because you've been dealing with that in your real world all the time anyway, right? So you're like, oh, I get rotation. We can rotate shapes as long as we know 3 things: about what point to rotate, in which direction to rotate, and how much to rotate, all right? And the original learning question, which I should have started with, but now if we go back and look at it, it is if an image, in this case a pre-image, which is the starting image, is rotated about a point, how can we find its new coordinate location, right? Vocabulary. Clockwise is to rotate to the right like the hands of a clock. Counterclockwise is to rotate to the left, the opposite of the rotation of a old school analog clock. Origin is the intersection of the x and y axis, right? This one's x, this one's y. The intersection here is at x equal to 0 and y equal to 0, or parentheses 0, comma 0, end parentheses on a graph. 360 degrees is the number of degrees by definition in a circle, right? Circles are 360 degrees. We made that up. Humans did. We decided it would be 360, and that's what gives us 90. 90, 90, and 90. 4 times 90 is 360, and it allows us to divide the circle up or rotation up into so many great parts. That's a definition, the number of degrees in a circle. And there's, I think, one problem given in the assignment, and it's got A, B, and C to rotate the triangle ABC different ways, clockwise, counterclockwise, and different numbers of degrees. Here's sort of a quiz, and maybe you've done the Schoology already. If not, this is in the Schoology. How many degrees, if we rotated this original image, how many degrees would it not matter which direction we went in? So this is 90 degrees. It mattered that we went this way, because if we had gone 90 in the other direction, we would have ended up here. How many degrees of rotation does it not matter which direction you go in?
360.
360 is true, because you would go all the way around and end up back here. And it wouldn't matter if you went that way or you went that way. You'd end up back at the original spot. Good. Very good. What's another one? That doesn't matter which direction you go in. 360 is good and true. And by the way, multiples of 360, like let's say 720, 2 revolutions, or 3 revolutions. It doesn't matter. If you went 3 revolutions this way, you'd end up there. If you went 3 revolutions that way, you'd end up there. Fair enough? So any multiple of 360 is very good. It doesn't matter. What else? What's another one? So how about 180? Right? Here's the starting point, and you tell me it's 180 degrees. 180 is, here's 90, and here's 180. So this way I went counterclockwise, right, to get there. But now start again and go clockwise. I'd go 90, 180. Didn't I end up at the same place here? So that doesn't matter which direction I go in if it's 180 also. This makes sense? Likewise, 360 multiples of 180. If you went half a revolution this way and then any number of times added a full revolution to it, like 1.5 times, 2.5 times, 3.5 times, you'd all end up back in this quadrant. It wouldn't matter which direction you went in, you would end up there. Pretty cool? Hence the whole idea of the circle and why we love the circle is such a fascinating idea, right? Because it always starts over and we don't know how many times it's gone around. Oh, another one would be, right, if you didn't know that it rotated at all, which would be kind of another fun one to think about. Okay, stop that, Leia. Please, please.